Okay, algebra students, this is our quadratic units. This is lesson 9, where we're actually comparing standard form with factored form. So we'll start with our warm-up. We have to just solve these equations mentally. So as I look at the first problem, we have 40 minus 8, which is 40 plus, and then we have to figure out, well, what's n going to be? So I notice here we have 40 and then minus 8, and then this would have to be 40 and then minus 8, but I'm adding. So I know that adding a negative is the same as subtracting. So n here is going to have to equal negative 8. Similarly here, I have 25 plus negative 100, which that's the same as 25 minus 100. And then I have 25 minus n, so that I can figure out that n has to be 100. Because if I rewrite this, this is 25 minus 100. Here I have 3 minus 1/2 equals 3 plus a number. Well, if I add negative 1/2, it's the same as subtracting a half. So I can figure out that n has to equal negative 1/2. Also, 72 minus n is the same as 72 plus 6. So when I minus n, that's the same as subtracting negative 6. So subtracting negative 6 is the same as adding 6. So n has to equal negative 6. So we're going to move now to show that x minus 1 times x minus 1 equals x squared minus 2x plus 1. And we have to show that they're equivalent by drawing a diagram and applying the distributive property. So we'll start with a diagram. This is going to be my length, and this is going to be my width. So here, we have x and negative 1, and x and negative 1. Multiplying x times x is x squared. Negative 1 times x is minus 1x. Negative 1 times x there is minus 1x. Negative 1 times negative 1 would be plus 1. So in pulling out my expression, we're going to write x squared minus 1x minus 1x, and then plus 1. I notice that I have some like terms to combine. Minus 1 plus or minus another 1 would give me x squared minus 2x plus 1. If we just applied the good old-fashioned distributive property, we have x minus 1 times x minus 1. So in multiplying, we'd go x times x, which is going to give us x squared. X times minus 1 would be minus 1x. Negative 1 times x would be minus 1x. And negative 1 times negative 1 would be plus 1. And then again, we can see we combine our like terms there, and we would get x squared minus 2x plus 1. So we can see that those are equivalent expressions. Now, here, we have to write equivalent expressions. So I'm going to draw both an area model. So here I can see in drawing that, we're going to have two parts. We have x and a plus 1, so x and 1, and x and minus 1. So x times x is x squared, 1x minus 1x, and then minus 1. Pulling my terms to the outside, we have x squared minus 1x plus 1x minus 1. We can see the plus 1 and minus 1 will cancel out, and you'll get x squared minus 1. To show that with the distributive property, we have x plus 1 times x minus 1. And to multiply that out, x times x makes x squared. X times negative 1 will be minus 1x. 1 times x is plus 1x. and then 1 times negative 1 would be minus 1. Those terms again will cancel out, and we'll have x squared minus 1. From now on, I'm just going to show these using the distributive property. So x times x gives me x squared. X times 3 would be plus 3x. Negative 2 times x would be minus 2x. Negative 2 times 3 would be minus 6. So that would give us x squared plus x and then minus 6. For our last one, I'm going to expand x minus 2 squared. Again, our base is x minus 2, and our exponent is 2. So this means I have x minus 2, the base, multiplied by itself 2 times. So that's really what x minus 2 squared means. And now I'm going to expand that with the distributive property. So we have x squared minus 2x minus 2x. And then negative 2 times negative 2 is plus 4. Combining our like terms, negative 2x minus 2 more x gives us x squared minus 4x plus 4. So we can see here, what form is it? So we're going to first talk about standard form. So standard form is when x squared, the highest power comes first, and then x, the second highest power, comes second. And then lastly, we leave our numbers last. So we write the x's with powers going from highest and then to lowest. So that's standard form. So now we have other quadratic expressions, and we have to see if they're written in standard form. So again, standard form is if I write ax squared plus bx plus c. So in looking at this, I have x squared and then 1. This is actually in standard form. So if I look here, the number in front of x squared this would be 1. So if I wanted to rewrite this, this is 1x squared plus 0x minus 1. So if we identified a, b, and c, we could say that a is equal to 1, b is equal to 0, and c is equal to negative 1. Similarly here, so this is standard form. I'm going to put a check mark by it. Also here, we have x squared plus 9x, and then we just have no constant, so I can write that as plus 0. So again, here we have x squared as the highest power, and then x, and then a constant. So this is, but I'm going to go back and identify what's my a, b, and c. So we have to figure out, well, how many x squareds? Well, there's 1 there, so a is equal to 1. And then how many x's? B is equal to 9. And then how many c's? Well, c is equal to 0. Here, I have 1/2 x squared, and I could say plus 0x plus 0. So again, this is in standard form. So we could say a equals 1/2, b equals 0, and c equals 0. Same thing here. This again is in standard form because we have x squared, x, and then a constant. So a is equal to 4, b is equal to negative 2, c is equal to 5. And then again here, x squared, x, and then a constant. So looking at the number in front of the x squared, or the coefficient, a is equal to negative 3. How many x's? That would be like negative 1x. So b is equal to negative 1. And then here, there's 6. So c is equal to 6. Now here, this is not in standard form because we have the 1 first and the x squared second. So not written in standard form. We could consider the standard form, though, if we switch them. We have negative x squared and then plus 1. Or rewriting that, that's negative x squared plus 0x plus 1. And then in which case a would equal negative means negative 1. And then b is 0, and then c is 1. So again, here, these are not written in standard form. So we're going to learn other forms. These two look very similar, and they also fit in with this one. So we're going to combine these and learn that these are actually written with factors. So we're going to learn that this is called factored form. That's going to be in future lessons. And then here, we're going to learn that these are other forms, and we're going to learn more about those later. So what are some characteristics of standard form? It's always of the form ax squared plus bx plus c, where a, b, and c can be any number. So factored form, when you use factored form, in factored form, it's just if you factored the products, I could expand them and make standard form. So in factored form, distributing makes standard form. So we could have x plus 1 times x minus 1. And expanding that, x times x would make x squared. X times negative 1 would be minus 1x. X times 1 would be plus 1x. 1 times negative 1 would be minus 1. Combining our like terms, we could see x squared minus 1. So this is factored form because we're going to have an x times an x, and then this is standard form. So we can move those. So in looking at our summary, a quadratic function can be represented by equivalent expressions. For example, f could be x squared plus 3x plus 2. This is in standard form. So in general, standard form is, like I said, ax squared plus bx plus c. And then we refer to the coefficient a as a number being multiplied by x squared. B is a linear term, the number being multiplied by x, and c is a constant term. So to talk about factored form, the function can also be factored. So x plus 2 times x plus 1. When it's a product of two factors, each with an x and an x, it's called factored form. So an expression in factored form can be written in standard form by expanding it. So we've done that in previous lessons with diagrams and the distributive property, and you can do that with all factored form equations.